Hello everyone, myself Shruti, working as assistant professor in Government Engineering College. I would like to, in this session, I'll execute a program using 8051 Keel software to perform 16-bit multiplication of a 16-bit and a 8-bit data. So this is the program. It is ready to be executed. It's in the debug mode. I have the data, 8-bit data in the 50th memory location and 60-bit, the 16-bit data in the 60th memory location. That is the memory location with the address 60H and 61H. Okay, now I'll start executing. I expect the end result to be available at 70H location. So I'll start executing as well as along with the execution, I'll explain the program. So first I'll take the number, 8-bit number into accumulator register. Next, which is this 8-bit number is available at 50H. So using direct addressing mode, I have taken the 8-bit data into accumulator register. Next, I'll take the next data, that is the lower byte of the 16-bit data into B register, and I'll use multiply instruction to multiply those two numbers. So once you multiply two 8-bit numbers, the result, the lower byte of the result will be stored in accumulator, and the upper byte of the result will be available in B register. Now I will store these two numbers, the lower byte data, lower byte of the result and the upper byte of the result in 70H and 71H locations respectively. See, lower byte number is 98. See, when you multiply 56 with E4H, the result is 98, 4C 98, right? So this is the lower byte of 16-bit result, and this is the 4C is the upper byte of 16-bit result. So those two bytes are stored here in 70H location. Next, what have to be done is you have to multiply the 8-bit number with the upper 8-bit number of the result. You can't at a time multiply the 8-bit number with the 16-bit number because 8051 is a 8-bit microcontroller. First, you have to multiply the 8-bit number with the 8-bit lower byte of 16-bit result, 16-bit number to be multiplied. You have to store the result, intermediate result somewhere. Next, you have to multiply the number, 8-bit number with the upper 16-bit, that is upper byte of the 16-bit number to get this result. And then you have to add those two intermediate results to get the final result, right? So this is how the multiplication is performed. But since it is a 8-bit microcontroller, this 8051 is a 8-bit microcontroller. First, you have to perform 8-bit multiplication. You have to take the 8-bit number and you have to multiply the lower byte of the 16, multiply this number with the lower byte of the 16-bit number and find the result. The result, intermediate results have to be stored somewhere. Next, you have to again multiply the 8-bit number with the upper byte of the 16-bit number to get the intermediate result again, and then you have to add up these two intermediate results to get the final result. So this is what is done in this program also. So next, 50H is, again you have to take 56H, that is the 8-bit number which is actually available in 50H location, into accumulator, and the upper byte of the 16-bit number have to be taken into B register. So when I execute this, B register has 1C. Since multiplication have to be done on the contents of A and B registers, these contents are actually saved somewhere. The intermediate result after first multiplication is saved in 70H location. So again, multiplication is done using multiply instruction, multiply AB instruction. So I will get this result 0968 as the result of this multiplication. So 0968. The lower byte of the result is available in accumulator, upper byte of the result is available in B register. Now what has to be done is I have to add, if you see here, I have to add these two numbers, right? So anyhow this byte has nothing to be added with, so I have to place it directly at the destination. Okay, so this instruction does it. So it is already available at 70H location. Since you need not have to do anything, it is left as it is. But this number has to be added with 4C should be added with the upper byte result, upper byte of the intermediate result of first multiplication should be added with the lower byte of the result of second multiplication. So to do that, the content of accumulator which has the lower byte of the result of the second multiplication is added with the content which is placed in 71H location. 71H location has 4C. So now we have to add 68 with 4C. So 71 location has 4C. So I am adding the content of A with 71H, with the content present at 71H location, and after doing it, that the result will be available in accumulator register. It is moved to 71H location. So I'll move that result to 71H location. So 4B is available at 71H location. Next, I'll execute. I am clearing accumulator register because at last I have this number. If a carry has generated, if a carry is generated from the addition of these two numbers, that is 4C plus 68, these two numbers have to be added. The upper byte of the 16-bit result first multiplication and the lower byte of the 16-bit result of the second multiplication have to be added with. So when you perform the addition of these two bytes, if carry is generated, you need to add it to the next number. So nothing else needs to be added. So I first clear the accumulator content and I'll add the content of accumulator with the content of B register. B register is having the upper byte of the second result, upper byte of the result of the second multiplication. So second multiplication, the result is added with the accumulator content along with carry if generated, but there is no carry generated in this case, so that is added, and again the result will be available in accumulator register. So the final result is placed into 72H location. So 72H location will have 09. Okay, that is the end of this program. So you have this program has performed the multiplication between 8-bit data and a 16-bit data, and the result is placed at 70H location. So that is the end of this program.